Hello, it's wonderful to be here with you virtually today. My name is Julie Shah. I'm a professor at MIT. I'm an AI researcher and a roboticist. And I'm going to discuss intelligent machine teammates and the future of work. The vision behind my lab's work is to develop robots, artificial intelligence, and computing more broadly that augments human capability rather than replaces us or supplants us. I've worked for many years in robotics for manufacturing, deploying robots that work alongside people to help build planes and help build cars. We have many examples of effective human-robot collaboration out in the wild in the world today. For example, in Amazon's warehouses, the shelves are actually robots, and people stand at the edges of the warehouse, and the product is brought to people to package, box, and ship. On the right, I'm showing a collaborative robot alongside a human associate on one of BMW's automotive lines. These are systems that don't need to operate in cages. They can work right alongside a person safely. But in both these cases, the robots are still working relatively independently from people. In Amazon's warehouses, the robots operate in their own physical space. And on assembly lines, the robots are really working independently, rather interdependently with people. So they're safe enough to work alongside people, but they're not smart enough yet to work with people. Now, there are somewhere around 1.8 million industrial robots in operation around the world today, which is a lot of robots. That's the same as the US population of Boston, Pittsburgh, and San Francisco. How many robots are there in our homes? Well, just in the US, I have statistics for the US, so that's what I'm sharing with you. Just in the US, actually, we have 30 million robots in our homes. And those are things that we look at and say look like robots, like Roombas, for example. That's not counting the Alexas, the Siris, our smart homes, which are now a type of robot, arguably. It's not counting sidewalk delivery robots. It's not counting security guard robots. It's certainly not counting autonomous or automated vehicles on our roads. And it's not counting, other robots that are popping up in our everyday environments. For example, on the right here, I'm showing you a picture of a strange googly-eyed robot that is deployed in hundreds of grocery stores across the country in the US, and it moves up and down the aisles to look for spills. My husband, who's a doctor, will frequently send me a new picture of a new robot in the hospital where he works. Now, for all these robots, many tens of millions or more, arguably, they don't really make an imprint on our public consciousness. If we were to ask, are we surrounded by robots every day? Most of us would say no. And that's because, much like in the other settings, in warehouses and in factories, these robots are coexisting. They're not collaborating with us. And that limits the value that they can bring to our lives. So these robots like Roomba and the grocery store robots, they're doing very well described, narrowly described tasks. They're doing it in structured environments and essentially under constant human oversight. So the question is, where are we going from here? What are the capabilities of these systems? How will they advance? And how do they have the potential to transform work and our lives? Well, they have the power to transform work in our lives in potentially negative ways, unless we get the development and the deployment of them right. Now, I'm showing you a picture here of a sidewalk delivery robot on the sidewalks of San Francisco. A little over 2 years ago, there were so many sidewalk delivery robots being deployed and tested in San Francisco that people felt unsafe. The elderly and people with disabilities, they went to the city and they say, we don't feel safe on our sidewalks. These systems don't see us. We're worried they're going to collide with us. And in fact, these systems don't see us as people. We are nothing but obstacles to these systems. They can't anticipate where we're going to go, what we're going to do, and they don't maneuver around us in the way we would expect of other entities on our sidewalks and on our roads. And so, in fact, in response to those complaints, actually, San Francisco paused the deployment of these sidewalk delivery robots. They relegated them to an industrial sector separate from people, and they regulated the number that could be on any given block at any point in time. Now, this is an indication. This is what we say is like the canary in the coal mine. While something will work at small scale in test mode, once we deploy it more broadly, it can have wide-ranging implications for safety, our comfort, and the usefulness of the systems. These systems need to be smart enough and capable enough to embed in our everyday lives, and they need to be able to interface, be used, and be directed by people that are not robotics engineers or PhDs. And so the goal here is what we want for our future is the ability to task these robots flexibly, to be able to deploy them in a way that is deeply embedded with how we do other work in our lives. So on an automotive assembly line, what we want to be able to do is, where it's possible and where it augments human capability and the productivity of the firm, be able to interleave the work of robots with the work of human teams that, for example, are assembling the car. So what does it require to take one of these human teammates out and put in a robot to do some of the work, or to improve the productivity of the team by introducing an additional robot teammate that can realize benefit through parallelization of the work? So this is what the future is going to look like. It's not going to be people and robots working side by side, but separated. It's going to be humans and robots working together more as humans work with other humans. It's going to afford us new opportunities to remove people from work environments that are difficult for health, for ergonomics, or in the case of the pandemic, for safety. And it's going to allow us to improve quality of work and productivity if we get the interface, the interaction between the human and robot right. In our hospitals today, much of the work is done manually. I'm showing you a picture here of a nurse manager on a hospital labor and delivery floor. And her job is essentially to be the air traffic controller of the hospital floor. So she takes in all the information from these LCD screens and the current state of the patients on the whiteboard, and she makes essentially air traffic control decisions. She decides which patients go to which rooms, which nurses are assigned to which patients. She controls aspects of the OR schedule. And she does this without any decision support. And so the future is in which we embed AI systems, AI intelligent teammates, not to replace this nurse's job, which cannot be fully replaced. These nurses train for decades or longer to be able to be proficient at this very, very challenging job. And it's not possible for us today to fully encode this optimization, tasking, and scheduling job that she does for a computer. We have tried. It is not possible today to solve those programs, even if you can fully encode them online fast enough. Humans are truly incredible. But we have extraordinary potential to fit together the capability of computation to take the easier tasks off the plate of these nurses and free up their cognitive capacity to handle the difficult and ambiguous situations, the difficult and ambiguous decisions that need to be made. So I'll show you a video of what the future can look like of embedding these AI technologies and these robot systems to augment our human capability to perform these very difficult tasks.
What is a good decision?
Right, and it kind of made me like,
I recommend placing a schedule cesarean section patient remark on. Nurse Meredith can take care of her.
like that's the
What is a good decision?
I recommend placing new patients in triage bed number 5.
What is a bad decision?
A bad decision would be to place a scheduled cesarean section patient in room 14 and have Nurse Kristen take care of her.
It's very specific.
Ginger, what's a good decision?
I recommend placing a scheduled infection patient in room 10. Nurse Meredith can take care of her.
I don't know if you plan to go back or what, but for me it was like this one. I always plan so much.
Ginger, what's a bad decision?
We are not
A bad decision would be to place a scheduled cesarean section patient in room 8 and have Nurse Amy take care of her.
I agree.
Now, in our controlled studies, what we found in deploying this intelligent robot system or intelligent computer decision support system, we deployed both variants, was that nurses and doctors accepted the system's recommendation 90% of the time. And so this affords a very important opportunity to embed this type of decision support, to embed service robots that can take initiative to suggest, to turn over rooms, to deliver linens, to deliver medications. And it's cognitively much easier for a person to accept a recommendation of a system than it is to do the mental computation, the air traffic control problem, to explicitly command and direct every action of both humans and now these increasingly complex systems that can and will be deployed in our environments. So this is a little bit of a glimpse. So this is a little bit of a glimpse of the future. But there are many challenges to making these systems more broadly useful. And I want to give you a sense of those challenges from a research study that we conducted as part of the MIT task force on the work of the future. So now we'll go back to discussing manufacturing. I'll give you a snapshot of the current state of robotics and the really substantial barriers we have to being able to make use of them in this more integrated way. We conducted interviews with manufacturers, integrators, OEMs, applied research institutions within Germany, France, and Italy. Our area of focus was looking at emerging technologies in industrial robotics, as well as IoT-based connective systems. And we asked questions and investigated the extent to which the technology has evolved over the last 10 years, how firms measure improvements through the introduction of new technologies, how they assess the value of these technologies, and then the remaining challenges and next steps for these technologies in manufacturing specifically. And what we found are a few very substantial challenges that we see exist in other sectors as well. First is the integration cost. Even if the system is independently capable of doing a part of the work and that work can add value, the cost of the technology of that robot system is only a fraction of the total cost of making it work in an integrated fashion with everything else that you have. Manufacturing, this integration is often performed by a third party, and so there can be very large costs and a very high barrier to entry for introduction of this technology. And every time you have to reprogram a robot, it requires substantial technical expertise that in some cases needs to be outsourced and is very costly. So now we're making an argument here that integration of these systems is where we see the value, but the integration costs are a very substantial barrier. And in fact, many firms do describe, the value of these technologies, not in terms of displacing labor, but that in fact, that's an outmoded or outdated way of thinking about the value of these technologies. And that collaborative robots, really the opportunity they afford us is in augmenting or assisting rather than replacing, just as in the examples I've presented so far. Now, how do you make the case whether integrating an assistive system can provide you productivity value and other benefits? It often requires a very substantial investment in simulation upfront, not just deploying, testing the system can do the task and putting it out in production or in the operational environment, but really developing high fidelity simulations of the different ways it can be integrated, the different workflows, much like human teams are their work is choreographed in many settings, or when it's not choreographed, we iterate and we refine how we'll work together and we develop a rhythm. We need to simulate and employ computation to sort of find that rhythm and the best way to introduce and integrate these technologies. For example, bringing simulation to the sidewalk delivery robots and anticipating the flow considerations of many people on a sidewalk with some of these systems would have been valuable upfront to understand and incorporate into the design of the sidewalk delivery robots that were previously deployed in San Francisco. Now, the deeper integration of human-robot work, in this case and in other sectors, is seen as the goal, but it's very much hindered by these integration challenges. Further, as we increasingly deploy these systems in manufacturing and out in the world, there's very little standardization for making these systems interoperable. Even between physical robot, like the physical aspects, like the flange is standardized, but really little else, and that's an impediment to innovation. And then finally, there's a driving need to be able to find better ways to leverage domain expertise, not domain expertise of programmers and roboticists, but those that are doing the work. Worker-centered approaches in which workers are deeply involved in the development, integration, and deployment of these systems have resulted in what we were told the most impressive and successful applications. However, line workers, sort of everyday people, people in shops, people in small and medium firms, they typically don't have the technical expertise to program robots. And the hurdles to integration, needing to outsource that to a third party, also provides a barrier towards leveraging the domain expertise. So what I say is that robots are actually programmed to be programmed by people that understand robots. And this is undesirable because people are the engine of innovation. From one of the interviewees, when asked about the potential goal of a lights out factory, we were told that, well, why would we want a lights out factory? A lights out factory is a factory that's not innovating. Innovation stops with lights out. And so there's a driving need here to enable non-experts to be able to program the task and remove the need to program the robot. Now, many of these difficulties impact small and medium firms to a much greater extent than they do larger organizations that can bring resources and leverage the external third-party relationships with integrators to overcome these challenges. So what is the way forward? Well, we need alternate ways to be able to program robots to do tasks and to be able to give them models of the environment and the people that they'll be working with. If we can unlock these two aspects, we have the ability to deploy robots more broadly across many sectors: manufacturing, hospitals, our regular workplaces, and our streets. And I want to show you two small examples of technologies that are moving us in the right direction. So first is the goal of being able to program the task rather than the robot. There is an increasingly growing field in learning from demonstration and programming by demonstration. So I'm showing you here work by my colleagues Nadia Figueroa and Aude Billard, performed at EPFL, in which we're making great progress as a field towards enabling people that are not robot experts to teach robots tasks. And we can do this through kinesthetic teaching, physically moving the robot through the task, teaching it the locations and relevant attributes of objects in the environment. And after a few demonstrations, enable the robot to be able to execute that learned model. Of course, many times we don't want to perform robot tasks just like robots, but we need these systems to be flexible and capable, especially when working with people, when people are the ultimate uncertain, uncontrollable entity. And increasingly, we are able to teach robots to perform these flexible tasks that accommodate these types of disturbances, are able to pick up the task according to schedule and still meet the constraints. In this case, they're scanning the object through that tube before placing it. And finally, once we're able to have non-roboticists program robots to do tasks, and robots can watch us as we do our own work and learn from that, we can bring together the models of the task and the models of the human to enable robots that can integrate and collaborate effectively with us as human beings. So I'll show you a task here inspired by sandwich assembly. Our human and robot will work together in meal preparation. The robot will fill cups with juice, the person will prepare the sandwiches, and they need to deconflict where they are in space at what time so they don't block one another or intersect or collide.
Hey teammate, let's make some meals. I will pour juice. Please make and wrap the sandwiches. Let's start.
So in this case, the robot is making decisions throughout the task.
Please make the next sandwich at 2.
As to where to go, what to do next, but also when to communicate with the person. In the case the robot is more sure what the person will do from its learned models, it does not communicate. If it's less sure, it might direct the person what to do, as it just did, or it might provide its own status updates so the person can use that in their own planning. In this case, the robot is not communicating because it does have a strong belief of where the person will be making the sandwich. Communication is not necessary.
I am pouring juice at 3.
In this case, the robot was less sure where the person would be, and so an effective teaming strategy is to provide updates about what you will do and allow the other person to use that in their own planning, which in this case worked very well for this human-robot team.
I am pouring juice at 4. I am pouring juice at 4.
In that case, the robot repeated its communication because even after the first communication, it did not have much better information about where the person would reach next. And so it repeated itself to help reinforce where the human's understanding of where it would be going. And so this is an example.
I finished pouring juice.
This is an example of what's possible when a robot is capable of performing work that's interleaved with human work, and the robot is capable of modeling the human's cognitive state, their intent, where they'll be reaching, and what they'll be doing. And we see in our studies that we can achieve substantial benefit in productivity, efficiency, worker satisfaction, and an ultimate benefit in terms of time to complete the task. And so this gives a sense of where the current state of robotics is today, the opportunities for these systems to impact our everyday lives and our work, and the emerging technologies that are on the horizon that will change the way that we all go about our work and the way we relate and engage with technology. And I'll share with you, a book recently out, What to Expect When You're Expecting Robots, in which my co-author Laura Major and I talk about the various dimensions we have to consider, societal dimensions down to technology design, down to ways in which everyday bystanders will need to think about these systems and help make decisions so that these systems can enhance our capability and our well-being for the coming decades. Thank you.
Well, thank you very much, Professor Shah, for a very fascinating presentation. And now for some questions from our audience. Our first question, what are the relative strengths of humans and robots? And how do we think about the trajectory of robots that work separately from people to robots that work with people? Is it just a matter of time until much of our work can be automated?
Well, I think that's really one of the key questions here. And one of the points that I'd like to stress is that we're not living in a world where the technology just determines our fate. It's not a matter of technology marching forward and we have to figure out how to solve for the undesirable implications or outcomes. In fact, we have the choice to shape technology towards the goals that we aim to achieve. And one of the things we show in our own work in my lab is that the problem statement for artificial intelligence and intelligent machines changes if you're developing those systems to do work that just replaces what humans are doing versus to interface and to collaborate. The challenge becomes, deploying robots that can do work that can be done today, but then making them capable enough and flexible enough to work with people and providing humans the flexibility in that interaction to use our best qualities, the qualities that we're going to have a very difficult time programming for machines in the long term, which is our creativity and our judgment. So the way I like to frame this is, humans and machines or computing capabilities, we have complementary capabilities. The way I like to describe this is, humans and machines, we're complementary. There are some aspects of what we do as humans that machines will never be able to replace. So a human's unique ability is the ability to take an unstructured problem and then structure it. Once we've done that, a machine or a computer can crush it. But the goal here is to be able to increasingly embed these intelligent technologies in ways that don't restrict our human ability to problem solve, that don't restrict our human ability to innovate and improve, as opposed to, freezing innovation, as we would see in a lights out factory with no humans involved at all.
A second question, what are the ways in which everyday people who are not developing robots and AI can think about their role in shaping the future of this technology?
Well, one example is if you just take sidewalk delivery robots. If we see value, as many people have in say in the pandemic, in having groceries delivered, then and other goods delivered, then there's a question as to in what ways we achieve that. So, for example, does a community want robots on their sidewalks? Or do they want robots in bike lanes? Or do they want robots acting as cars on our roads? Now, your choice as to whether these systems are deployed on sidewalks or in bicycle lanes or on roads has very substantial implications for your everyday life as you intersect and interact with these systems. And it also drives the requirements for those systems. A system on a sidewalk will maneuver slowly, which has some safety advantages, but it needs particular sensors and it needs particular planning and prediction capabilities to be able to handle many different entities, pedestrians, strollers, dogs, and that introduces particular challenges. You can imagine a different paradigm where a community says these systems should operate more like bikes in their own in bike lanes. And in that case, the speeds that the systems will operate, the ways they interact and negotiate at intersections is going to be very different than, for example, sidewalk robots. And that will drive a direction of technological development. And same on the roads. You can imagine yet another option where communities determine in collaboration with the manufacturer that these systems will operate as their own entities in lanes, say, next to bike lanes. But of course, that has implications for infrastructure and investment at a municipal or at a city level. And so, these are questions and decisions that can and should not be left up to technologists and particular companies, but need to be made in conjunction with communities because these decisions will have long-term implications for the success of the system as well as their impact on our lives.